All right, so here we're going to look at just the first example problem. So the first example problem is analyzing a position versus time graph. Okay, so what does this look like? How can we interpret this graph to get the correct answers, right? So I can see the questions to the right here of the graph, but I wrote those questions. I know what they say, but I just want to start, the strategy would be start with the graph, right? You can pretty much answer the questions before you even look at them by looking at this graph. And we can break down this graph easily, right? So because of it being straight lines, I know it is constant velocity, right? There's no parabolas on here, or what you guys would say there are no curves, right? They're either slope lines or horizontal lines. So I know it's going to be a constant velocity. Now, I have two areas of rest. So here I'm resting, here I'm resting. How do I know that? It's because I have a flat line. Okay, I have a horizontal line which horizontal lines have slopes of 0. I'm just going to keep a little bit of a timeline down here of where things happen. So where my graph changes. So here's my rest areas. All right, so what amounts to my second and fourth segments. Okay, now do I have an area of positive velocity? Yes. I have one area where I'm increasing from left to right. So this is my positive velocity. And then notice I have this area of a negative velocity. Now, I don't know what those numbers are, right? I'm just kind of going through and identifying conceptually what is happening here with this graph. So from 0 to 3 seconds, I'm increasing my velocity, or I have a positive velocity. From 3 to 5 seconds, I'm at rest. From 5 to 8 seconds, I have a negative velocity. And then from 8 to 10, I am at rest. Now, one thing to note, the positive velocity and negative velocity does not mean I'm speeding up or slowing down. That just means I'm traveling in the positive direction, okay? Or for the positive velocity. For my negative velocity, I'm traveling in the negative direction, okay? So you can note that by saying, here I'm going up, right, to 6 meters, resting at 6 meters, and then I turned around and came back down to 3 meters, and then I'm resting at said 3 meters, okay? So there's my analysis of the graph, okay? Now, let's answer our questions. During any time, so part A, during any time intervals is the object being accelerated? Why or why not? Well, what did we say here, all right? We said it was constant velocity, so are we accelerating this at all? No. And what's our reasoning? The graph has straight lines. And we know, based on physics, straight lines means constant velocity. If it was accelerated, the lines would have been parabolic in shape. Okay? Now, part B, what time interval or intervals is the object at rest? So they like to do this with this parentheses S to get you thinking that there has to be more than one answer. But in actuality, there could be only one, it could be 2, it could be 3. Now, for us, part B is the answer where we said rest. And if you look here, we have rest, we have rest. Okay, we have rest from 3 to 5, we have rest from 8 to 10. So 3 to 5 seconds, 8 to 10 seconds are our two areas of rest. All right, now part C, what time intervals is the object moving with a positive velocity? And then what is that positive velocity? Well, we're moving with positive velocity from 0 to 3 seconds. How do we know? Our graph increases from left to right. Okay. Now, what is that velocity? Find the slope. So we know velocity is change in position over the change in time, right? So we're going to do final position, which is 6. Our initial position is 0, and then divided by our final time, which is 3, divided by or minus our initial time, which is 0. So we have 6 over 3, which is positive 2 meters per second. Yes, I understand that your calculator or in your mind that if I don't put a positive number, it's always assumed to be positive. But in physics, you can't make that assumption. You have to put the positive or negative sign, okay? Because our question actually asks for a velocity. Right? If you don't, I don't make the assumption that you think it's a velocity. I make the assumption that you think it is a speed. Okay? And then part D, what time interval or intervals is the object moving with a negative velocity? And then what is that negative velocity? So here's our negative velocity segment. It's from 5 to 8. Okay? It's that downward sloping section. So we're going to go from 5 to 8 seconds. That's our negative velocity. Now, what is that negative velocity? We're going to do V equals our delta x over delta t. All right, and so we're going to do our final position, which is 3, minus our initial position, which is 6, and divide that by our times. So 3 is at 8 seconds. All right, this gives us our time interval. So 8 minus 5 is 3. So you're going to get negative 3 over 3, which is negative 1 meters per second. Okay, so again, I see that you guys are doing a good job of, answering each other's chats. Thank you for doing that. Okay, so again, we have to put the negative sign because it actually gives us a velocity. And our negative sign or a positive sign actually comes from our top part, right? Our change in position. So this determines that if it's going to be a positive or a negative sign, because our time is always going to be negative. Okay, or excuse me, it's always going to be positive. All right.